Okay, greetings all. Thank you very much for joining today. I noticed looking at myself, this is the David Lynch Friday, obviously. The subject is describing the circular economy as well as giving you a description of what a material flow analysis is all about. And part of this was more or less spurred on by an event that took place last week that I was asked to host. And one of the problems were tied to the subject matter per se. So let me go ahead and explain to you what that problem was about. Yeah, I was asked to go ahead and give a presentation on the circular economy tied to business analysis. Now, this is a profession that I had been involved with for a number of years, and I thought that this was a very good fit where the capabilities tied to business analysis are clearly needed for us to reach circularity. And so the host of the webinar came to me and said, all sounds good, Mike, but there's one problem that most people have no clue as to what you're talking about, what the circularity is about. And so I thought it would be good to go ahead and share this information with you. It was a poll that we took using Mentimeter during this webinar. And as you could see on your screen right now, these results are abysmal. So 16 of the 28 who actually went ahead and filled out the poll online, 16 said they had no clue about circular economy, and 11 of the participants said somewhat familiar, which is probably pretty close to knowing nothing, and only one person said that they were very knowledgeable about the subject matter. And so I thought it would be good for us to actually go ahead and take a step back for a change and look at what this actually means. So let me go ahead and move on to the next slide. And I suspect that a number of you are familiar with this concept. And in fact, I think what I'm going to do is put the cats to rest. It was a nice idea, but I think it's run its turn. 1 second. Thank you. There we go. I could come out and explain the butterfly diagram, but I thought it would be much easier to keep it much simpler. This is, for me, the basis of our problems. We take from nature without returning. We make things that people might need or maybe not, and we consider that to be growth. And at the end, we toss it away. And so we say that there is a solution. It's called reverse logistics. And this all sounds great on paper, but the problem is as follows. In reality, it doesn't really work, because what happens is it ends up going ahead and being compiled, looking at it from a pure economic perspective. And these kind of scenes are the results of this reverse logistics. And of course, some of you might have heard the reports that came out during the last Christmas season. This is all tied to e-commerce. 5 billion pounds of returned goods end up in US landfills each year. 5 billion pounds. Now that is a lot. And the question is this really sustainable? I think it's quite clear that we need to come up with some better ways to go ahead and solve this one. So this is something I'll be talking about a little bit more into detail later on. I thought long and hard as to how do we go ahead and bring this message of circular economy to people who perhaps are not quite familiar with the concept, understand the premise all too well. It's just that we do a very poor job of explaining it. And I brought it down to 3 components. 3 components. And I'm going to start with this finger, putting it down, because otherwise I'm going to send a very insincere gesture. So we start with the awareness. We need to go ahead and make sure that people are aware of exactly what the problem is. And very often they think they're doing something sustainable, and then you go ahead and point out what their processes are, and they realize actually they're not that sustainable. And I know this one quite well because it applies to me, and this is something that actually happened to me. So once we've gone past the awareness part, we move on to the instruction. That means, oh, now I know that what the problem is, but I don't know how to get away from it. I don't know how to escape this. And so then we need to go ahead and make sure that we come up with proper instructions for individuals to show them the way out. And that could be individually or collectively. Certainly as a society, we have this problem collectively. And then the last one is incentives. So we solved the awareness problem. We had attacked the actual instruction problem. But if we don't come up with a solution for the incentives problem, we really don't make any progress. And so this is something I'll talk about a little bit more into detail when we get closer to the end of the actual live stream. One other point I'd like to raise, and those of you who have been following me are perhaps quite familiar with this slide, it's not really circular. It's an ecosystem, and it goes every which way but loose. And that's part of the problem because our minds are not used to actually going ahead and looking at things from a non-transactional approach, something that's non-linear. And so we have a number of if-then scenarios to be found within this model, and we need to get used to actually going ahead and thinking different. But as I mentioned, the main part of this live stream is to be concentrating on this concept of material flow analysis. And here I have to explain to you, this is something relatively new to me as well. I didn't really think about the necessity, and here I'm just being quite honest. But there was a point in time where I realized if indeed I am not capable of going ahead and depicting the entire end-to-end process, starting from the resources on the one hand, all the way to what we actually do with the waste, then we're never going to be able to solve the problem. And I know I have a number of individuals who are attending today that I'm speaking to the converted. The best way to solve the problem of waste is not creating it at all. And so that's going to be the basic tenet of what I'll be talking about. First off, let me go ahead and explain to you what you're looking at on your screen. Let me make this little one a little bit bigger. This is a material flow analysis that was coming from the city of Charleston, and this was not come up with me. Rather, this is a depiction coming from the company called Metabolics, a company from Holland, who were the ones who were responsible for doing the analysis for Charleston. So let's go ahead and take a look of what you can see over on the left-hand side. Going from top to bottom, we have the number of households, and I won't spend too much time concentrating on numbers. And then moving forward, we have the commercial. Very possibly, it might be a little bit too small for you to read. Apologies for that. And in essence, the idea was not to go through all the details blow by blow, but to give you an idea of some of the components that you can use to look at a material flow analysis. And then they put a big emphasis on construction sector. As some of you might know, that 25% of our CO2 footprint is actually coming from the construction sector. And then lastly, what's coming from the public sector. And so let's go ahead and take this journey together, moving from left to right. As you could see from these 4 streams appearing on your screen, we have a total waste, and I have to move closer to the screen here, 1,064,063 tons. That's a lot. And what they did was they broke down the waste into various components, as you could see, starting with plastics, going on to textiles. I don't need to go ahead and read off the list. You can go ahead and follow it yourself. A couple of components that are worth noting would be electronics and paper, and then lastly, organic waste. So what actually happens to this waste after it has been collected? You could see that the lion's share ends up going to a landfill, and then we have the components on the top, which would be the recycling. And it's very interesting here, if you could follow the colors, most of the recycling is coming from paper. Difficult, I suspect, for you to read on your screen, but some of it's coming from electronics, some from glass, some from metals, some from textiles. And then you could see down below the organic waste, which would be 56,620 tons. And based upon my experience, and been working on a project in the area, that of that organic waste, it's pretty much coming from the tree shrubbery. And so we're not really looking at food waste per se, but we're concentrating primarily on those things that we didn't know what to do with. So we went ahead and kind of got rid of it that way. Let me go ahead and take a look at some of the components that are be found in the chat box, some of your comments. There's one coming from Stella Wittmann. Our politicians have to implement the goals for circularity. If not, we will not reach Agenda 2030. Well, that was a clear, that's a no-brainer. I'd like to focus on something that John Gosmosky is posting here. I choose product for the packaging and don't buy it all. Eventually, you have this circular, but realistically, products like e-waste have been an example of something that is hard to recycle. Yeah, so really, the problem is that we wait way too long in this process, and that's going to be one of the points I'd like to go ahead and raise to all of you. We are way too late in actually going ahead and addressing the problem. What we need to do is stop it before it actually gets to waste. Let's continue. Maybe before I go here, let me go ahead and explain to you what is behind me. This is a typical material waste analysis, and I'm going to try to do it like the weather people, because this is behind me. We have our, let's go this way. We have our inputs, so we have imports coming here. We have the imports outside of your area, and then we have domestic extraction. As you can see in this example, there's quite a bit that's taking place locally. That one's quite easy to determine from this map. And then we have our process materials, which is 7.4. No need to go ahead and concentrate on the number because that's not the objective. But once we're able to go ahead and break this down, it gets quite interesting. So of that 7.4, 4.3 are going into material use, and 3.1 is for energetic use. That means that there's a high use of energy within these process materials. And then let's concentrate at the end, and then we'll move on. We have our domestic process output. Out of all of the 7.4, we have 2.6 are the what's left, and then we have our domestic process output waste, which is 1.5. So there's a fair amount that ends up as being waste, and we're not even talking about how we go ahead and break all of this down. And so as you can see, there's a standard notation for a business, process flow analysis. And so I thought it would be good to go ahead and give you a brief description on that, but that alone doesn't really go ahead and show the real crux of the problem. If we concentrate only on material waste, then we're missing so much of the equation. And this was a model that I started putting together just to get my head around this concept a little bit better. So let me go ahead and describe this one for you. Looking at import and export, that one's clear. We saw that in the model that I just showed you. But we need to look at it from an energy perspective and also a water perspective. Later on, I put together a flow tied to microplastics, and I'm hoping that this particular point becomes very clear. So either this material is being imported, or we are receiving it from local production. As you saw in the example earlier, there was a lot of domestic production taking place. The vast majority was being managed from the domestic production. And of that domestic production, some of it's going to be exported. Now, I go ahead and ask a question of you. If we go ahead and produce it and we send it somewhere else, does that mean that the CO2 footprint does not exist? Yeah, I thought you would come to the same conclusion. So let's move on. So we have our imported materials. And again, I think it's important to look at it from an energy perspective. So you could also look at it from an emissions perspective and also from a water or a sewage perspective. Then we have our local production, that being exported, and the the little icon in the middle is supposed to represent the urban area. So we'll have our imports, we'll have our local production, and then of course, what comes in must go out. Now we've reached the waste part. And here on the waste, we should also look at it from a local waste. In other words, does the waste stay local, or do we go ahead and export it somewhere else? Because again, this is a great example of where we see this on a municipal level, and we also see it on a company level, that we will go ahead and outsource our waste somewhere else. And we said, oh, we've been able to go ahead and reduce our CO2 footprint. And that is like one of the purest forms of greenwashing I've ever run across. And I think it's very important that we ask the right questions. And it's also very important that we're able to depict the entire end-to-end flow, because without being able to do that, we're never going to get our heads around all of this stuff. So let's go ahead and move on. Yes, I have an example that I'd like to go ahead and share. That means I am moving back. One second. All right, now this is a depiction that I put together on a Miro board. And this is in conjunction with some circular design sprints that will be coming up here soon. And the example that I will be giving you today is tied to microplastics. And the goal here is to give you a very brief description of what it looks like, how the plastics are actually going ahead and being created, and then what that process looks like. And we'll concentrate on 3 products that are primarily the culprits tied to microplastics. And I'd like to go ahead and show you the effect of all of this. So this is our first attempt at working with a Miro board here and doing a live stream. So of course we start with the actual petroleum extraction. So we have petroleum is drilled and transported to a refinery. Make it a little bit bigger. And we have 2 components that are main focus, taking from the petroleum to create the plastic, and that would be ethylene and propylene. Sorry, this is not my specialty. Apologies for that. I have trouble enough with simple names like Mary and Joe. Let's move on. Then we go ahead and put these components into the reactor. And that leads us to the next stop. Let's move on. And this kind of got mixed through, but that's fine. We're going to go ahead and freestyle it. So we have, let's move that one to the side. We have what's called fluff, and the fluff is the powdered material, or the polymer that's created, and it kind of looks like laundry detergent. And then after that, we go ahead and create a fluff cocktail. And basically what we're doing here is putting together the plastic in a form where we can go ahead and create pellets, and we use an extruder for this process. And we're almost finished with our lesson for today. And then we end up with the pellets. Now, so far so good. This seems pretty clear cut, but now this is where it really starts getting interesting, folks. So let me scale out. So did you know that very often we will go ahead and fill our toy or our toy bears or whatever they might, stuffed animals, with these plastic pellets? Now we think, oh, that's great. That would be a very efficient way. And then of course you could rattle the stuffed bear and you could hear the click clack and you think, isn't that great? But what we don't think about is some of the undue effects that take place by putting plastic pellets into stuffed animals. So very often they're handed over to dogs, and the dogs think it's great, and so they hear the noise and they want to go ahead and chew at it. And so how long is that stuffed animal going to stick around? So I ask you a question now. If a stuffed dog is going to gnarl away at a stuffed, is a dog going to go ahead and gnarl away at a stuffed animal? Do you think that little babies are going to gnarl away at these stuffed animals as well? So do we feel comfortable about leaving a situation where plastic is actually put into various toys like this? Again, I just want to go ahead and put that in as food for thought. So let's go ahead and move on. Let me go ahead and move this to this side. So we have the pellets and we go ahead and transform them to, or transport them, better said, to a warehouse. Once we've gone ahead and, of course, within that transport, we're creating all kinds of emissions. We see within the various parts of this process, we have emissions all over the place. So let's go back. We have our warehouse. Let's move on. And then we get to our manufacturing, where, of course, we have more emissions being produced. But again, I like to go ahead and concentrate. Let's see how this one looks. Yeah, it looks all right. Let's concentrate on the three elements that are the major culprits of microplastics, those being tires, cosmetics, and textiles. So I'd say let's go ahead and start from top to bottom. And this is probably one of those factoids that most people are not aware of, that tires are one of the major culprits in creating microplastic. And if you think about how tires are used, it should be a no-brainer. In other words, the tires are running on a road, as you can see, and the wear and tear is creating the microplastic. And I certainly fell into the group that didn't realize that we're using plastics to make tires. I thought it was made out of rubber. No, we're actually using plastics. So what happens is, let's go ahead and follow this path. So we have the tires, they're on the road, and of course it rains. So what happens to that microplastic that was washed away from the roads? Yes, it ends up in our lakes and rivers. And of course, the lakes and rivers are in continuous motion. And if anybody's familiar with general geography, a lake, let's go look at it from a river perspective. A river does not stay static. The river keeps on moving and eventually ends up in some sort of sea. And of course, that's where the microplastics are being eaten by fish and other living beings within our oceans. And that's how the tires go ahead and contribute to the microplastics to be found within our oceans. But that's only one of our problems. Let's go ahead and move on to the next one, which would be cosmetics. Let me go ahead and zoom in here. And you might think, well, where does microplastic actually come from cosmetics? We have what's called microbeads, and it's a major component, or it has been a major component of cosmetics for a number of years. There's a big effort to actually go ahead and eliminate them. There are laws coming in the EU where people will go ahead and say, oh, well, we have a law against that, so we don't have to worry about it anymore. Well, of course, that's assuming that anything that we ever use in the EU is coming from the EU, for starters. Number two, just because we in the EU have solved this problem doesn't mean that the rest of the world has the problem solved. And so we should not be perhaps so sanctimonious that we're able to solve the problem in Europe. But let's go ahead and continue with this story. So the cosmetics are used, and of course, when it's finished, it either ends up in a landfill. That would be the dump truck that you see. And of course, when we go ahead and put things into a landfill, that is our biggest source of methane. And this is a depiction of methane. But of course, it doesn't just go there. There's possibility that the cosmetics might end up getting burnt. which means that, okay, so great, we were able to burn it, so we create energy. That would be the lightning rod over to the right-hand side. But have we ever thought that there are ashes and perhaps some other debris that's coming from the burning that we don't quite capture? And then there's this wonderful energy that we actually put into our disposal every once in a while, and it's called wind. And the wind could actually go ahead and blow it into a lake or a river. And voila, we have the same problem as we have with the tires. That would be one. So we either have the landfill or we actually go ahead and burn it. Not a pretty picture. So let's go ahead and concentrate on the one that might even be the biggest headache of all, because there are so many touch points for the microplastics to take place. And that would be with textiles. So we go ahead and produce the textiles. That alone is using energy, which is emitting CO2. But to treat the textiles, we need water. So that means right from the bat, we are creating microplastic. So it goes, we use the water, goes into, let's go ahead and stay with the river, and bingo, it ends up as microplastic in the ocean. But we're not finished yet. So let's continue with this story. The textiles are made into clothes, and the clothes, of course, need to be washed. So we take them off the rack, we put them on, we put them in the washing machine. Bingo! Again, we are creating microplastics through washing the clothes. That goes into our rivers and again is deposited in the ocean. But of course, we're not done yet. And this is where the textiles become our triple threat. Either they are sent to the landfill that helps in creating the methane, or we go ahead and burn them, and then we follow that process as you see on your screen. Best case, we consider ourselves being very productive when we create energy this way, or very possibly it will be blown away and end up in a river. And of course, we know where it goes from there. And yeah, so that was a brief lesson as to what is actually going ahead and taking place with microplastics. And I think it's very, very important to understand the entire process, to understand that once we get to the disposal part, we are way too late. We need to go ahead and solve the problem much earlier in the chain. So let me go ahead and move back to my presentation. 1 second, please. And here, friends, is really where I see the biggest problem. We only concentrate on what's called end of pipe. End of pipe means that once we've gone ahead and created the waste, then we start thinking, well, what are we actually going to go ahead and do about it? And I'm hoping through that depiction that I showed you, and that was only one example, using microplastics as our example, that's way too late. We need to go ahead and look much farther up in the chain, sorry if I can get this one here, right? Here, let's do it this way. We need to go ahead and concentrate here in our material flow analysis and making sure that it never gets down to this point. And I have to be very dexterous doing live streams using these processes. And we have our emissions, and then we have our actual waste. We need to go ahead and start earlier. Sorry, this way. We like the weatherman. We need to start concentrating here in the process instead of waiting to go back here to actually solve it. And that's really what we need to put our energies towards. So, and we have some other challenges that, apart from the fact that we always wait till end of pipe, but we've created these industries that thrive on our waste. And here is the statistic coming out of the United States, and you can see from the depiction here that we have gone from 1960 to figures up to 2017, and you could look at the amount of solid waste generation in millions of tons that's actually being generated. So this number has gone exponential, we can go ahead and say, well, after the year 2000, it hasn't grown that much. This is still bad news, folks. And there's something that I'd like to go ahead and describe to you that makes this one even worse. This industry, again, I'm only concentrating on the United States. Waste management is $112.2 billion business. This is a $112.2 billion business in the United States alone. And these are figures coming from 2019. And so I really raise the question, if you go to these individuals, these companies, the people that are actually running the companies, and you tell them, oh, we need to go ahead and get rid of waste. Do you really feel that they're going to say, yeah, sure, we've been waiting for you all our lives, and this is no problem? And I would argue that we don't even need to go to the private sector, that the public sector probably isn't too much better, because anytime you go and say, we actually want to reduce those things that you do, then there's going to be a natural resistance from those individuals who are going to want to go ahead and put up their dukes, and they'll be fighting you the whole way. So there needs to be a better way. And of course, I don't want to go ahead and leave you with these negatives, but one last point that I'd like to raise, and then I'll make sure that we close this one on a positive note. You might have heard, these are some of the ideas floating around, the most prominent coming from Elon Musk, or perhaps even from Bill Gates, that we would take carbon out of the sky. And so the question is this carbon capture, which of course, please don't get me wrong, I'm certainly not against technology. And I do believe that we need to go ahead and figure out inventive ways to solve this problem. But inherently, there is a glitch with this concept. And I'd like to explain to you this concept. Is called Jevons paradox. And let me tell you the story of Jevons, who was an economist going back to the Industrial Revolution in England, where the cities were abominable. You could not live there. And of course, there was already an uproar. And so people were going ahead and making a complaint about that situation. And the scientists, or those clever people, were actually going ahead and saying, yeah, but we're actually going ahead and coming with much better ways to go ahead and use the material, which means that basically we're reducing the amount that we need all the time. And so Jevons went ahead and performed his analysis, and he came to a certain conclusion. And he said that basically the more we save, the more we use. And I can come up with so many examples. And I think if you think about it yourselves, you will come up with all kinds of examples of where this actually plays through. So if we have more bandwidth, we build apps, we build different computers or mobile phones or whatever that need more bandwidth. So the more we have, the more we use. If we have more petrol, the more we have, the more we use. And of course, the real fear is going to be the data industrial complex, where basically we think that we're solving the problem with e-cars, but in essence, all we're doing is following Jevons paradox one more time, where we will even be spending more time in our cars. And of course, we are paying with our data. I promised you that we would end more on a positive note, and so let me go ahead and move to that. As I mentioned, we have the three pillars of how we are able to go ahead and get everybody on board with regards to the circular economy. And I would like to go ahead and highlight something I put together. I'm trying another experiment here. Awareness, instructiveness, and incentivize. And as you can see, the incentivize is great with the green screen. That means we're making the incentives very transparent. So let's go ahead and walk through this example a little bit more in detail. So we have our awareness. We go ahead and make sure that the individuals in our society are all aware of what's actually taking place. That's a lot of work. We shouldn't underestimate the work that we have in front of us to make sure that everybody is aware. If I go back to the beginning of my presentation and highlight the number of individuals who were not familiar with the term circular economy, then that alone should be enough of a wake-up call for all of us to realize we have a lot to do. And I personally believe this is a duty that we all need to go ahead and take on for our own. Make sure that we are able to make those people close to us aware of what is actually taking place, and perhaps through the example that I gave with the microplastics, perhaps something along those lines might be something that we can take up and make sure that people know that when they go ahead and buy these products, when they go ahead and perform these activities, these are the results. And I'd like to give people a bit of credit if you tell them in a way where it's not accusatory, and understanding that we are possibly very much creatures of habit, and we do not always know what we're doing. We don't have enough time to actually think it through. Then it allows them to understand the necessity of change. And the fact is, change does not take place here. Change takes place here in the solar plexus. So if you and I and everybody else could actually go ahead and pass that word out that it's time to change, then that would be a very good first step. So let's go ahead and move on to the next one, which would be instruction. If we are aware and we don't know how to move forward, well, that's a bit of a problem. And I run across this one quite often, and perhaps you have as well, that people want to do something good, but they don't know where to start. And so if we collectively can try to come up with best practices, and I see all kinds of comments that are coming through in the chat box, and thank you very much for that. I think that just maybe highlight some of this is coming from Konstantin. It seems that people do not know about this problem, and I would agree wholeheartedly on that one. John came up with a comment, lots of plastic on cars. And yes, John, you are completely correct on that one. So let's go ahead and try to find ways that we can make sure that people are actually not just aware, but they know how to move forward. But my big point here is if we're not able to go ahead and create incentives for everybody to understand it's in their interest to go ahead and continue once we've gone past the awareness, once we've gone past the instruction, that we have incentives to keep on repeating this, then only at that point in time are we going to make progress. And here we come to the magic moment where we actually answer the question, what is a circular economy? Yes, a circular economy is when you have incentives for people to go ahead and live in circularity. And unless we're able to come up with these incentives, the incentives for people for our system to work properly, that people know what to do, that everybody can actually go ahead and thrive, we're never going to reach these goals that we keep talking about. So please do not forget, we have the awareness part. We need to make sure that people are aware. We need to go ahead and build in the instructives, but we need to come up with incentives. Incentives are very important for us to actually go ahead and really, really, really reach our circularity. So, a couple last points I'd like to go ahead and raise, and then leave it for any possible questions. Trying to keep an eye on the chat box. Everything that I've been pretty much talking about so far has been concentrating on this teeter-totter on the lower part, which would be the degradation. Today is not the day for me to use these such words, I can tell. That means that we're destroying in all of what we do. What we need to do is change the balance on this teeter-totter and make sure that we work towards restoration. In other words, we need to build back and to make sure we come up with structures that allow for these things to work properly. So we move away from degradation and we move towards restoration. And then another point I'd like to go ahead and raise, and perhaps some of you are familiar with this one, those of you who have heard of permaculture, for me, this is one of the best part of the permaculture. For those of you who are not familiar, it was I would actually call it a way of working, a way of living that was actually put together in 1978. So we're talking about something that has been around for 43 some odd years. And the best part about this model, it is very, very simple. Very simple. So let me go ahead and explain this one more in detail. And there isn't too much detail to it. We just need to go ahead and concentrate on three things. Three. We care for the earth. And of course, we talk about this one a lot. We talk about caring for the earth. And we seem to be, that seems to be our focus. But what we don't do such a good job on is the one over on the lower right-hand side. Care. Let me go into this one. Care for people. Because we keep thinking it's just about the ecology. And if we're not able to go ahead and concentrate on the people part, then we're always going to have a problem. And here I would go ahead and say that this is the secret sauce that you find within the ethical foundation, and that is returning the surplus. So that means if we have something over or something left, then we go ahead and bring it back into the system. And that is what we call natural growth. I don't know how many of you have ever really thought about it. Isn't that the way that nature works? And so can we go ahead and learn with the way that nature actually goes ahead and manages her business, which is actually should be our business because we're part of nature, that is the way that we can actually go ahead and move forward. Okay, well then, thank you very much. Thank you very much for joining today. Let's see if I can come up with anything in particular coming from the chat box. I see that there are all kinds of conversations that are taking place within the chat box, so that's good. I always think it's quite healthy if we're able to go ahead and create a dialogue between everybody. And so I think with that, I'd like to go ahead and thank you for attending this live stream. Spur of the moment, there are a couple of events that perhaps if I could take advantage of the opportunity to highlight. One is taking place on the 8th of April. It's called, let me go ahead and make this a little bit different, Frugal Entrepreneurship. And the idea is if we're ever going to reach circularity, we need to go ahead and look at how we produce our products and services in a much more frugal way. And based on what's often called constraints-based innovation. And so we will have a number of guests coming from various parts of the world. I'm really looking forward to that. Be less talk from me, which I could tell maybe I should talk a little bit more. I was a little bit out of shape, but never mind. That will be taking place on the 8th of April. And then there's another event coming up on the 12th of April, and this is called Workforce Management. Workforce management and circular economy transitions, where we will have talk about an application that was put together to come up with probabilistic models to understand. So what's the effect that we have on the workforce if indeed we have a change tied to adjustments on the circular economy. And then this is coming much later. Presentation we'll be doing on some work that we're doing here in Vienna. That's all tied to the 15-minute city. So if you find anything of interest, please feel free to go ahead and visit either the Circular Experience site or perhaps the Circular Vienna site and sign up for that. Apart from that, I would like to wish you all happy holidays. Wish you help and speed in actually getting past this pandemic. And I'm very appreciative for you actually going ahead and sticking around until the end. Thank you very much, and look forward to seeing you at our next live stream. Thanks again.